Hello, Lake Erie Council. I am so excited to be back today with you all, and we are going to do a super fun, super exciting adventure. Our bear super science adventure is what we're up to. I'm here with Jared, and we're going to have some fun doing some science experiments. Hey,
Good
Jared.
afternoon. Happy to be here. Science is one of my favorite subjects, and can't wait to do our experiments today.
Awesome. I am super ready. Do you want to start off? I think we have a gathering thing that's going to be exciting. Can you stand up and show us how to do it?
Absolutely. So we're going to do our first experiment that we can all participate along with for our gathering activity. But since we're scientists today, I've got my lab coat to put on.
I've got mine too.
And safety first, we want to have our goggles, keep give ourselves some eye protection. So today, one of the things we're going to be learning about is static electricity. So what I'm going to do here is I got my socks on in my carpeted room. I'm going to shuffle my feet around. I'm going to try and build up static electricity. I'm sure you guys have all done this before, or sometimes intentionally, sometimes you're surprised by it. But we're going to see if we can build up enough electricity to create a little static shock here.
I think you can do it, Jared.
Sometimes my cat does this to me by accident. He'll like jump up on the bed and he'll stick his nose on my nose and he'll give me a little shock. Let's see if I've got enough here now.
My puppy does that too.
All right, here's a little metal handle and
Ooh,
it worked.
awesome. That's so cool. So I can't do it
for scouting.
I have hardwood here, but at my parents' house, I do it all the time. I'm like, woo, where'd that happen? Awesome. So we're going to start our meeting like we always do every meeting. And we're going to start with the Pledge of Allegiance.
All right. We've got our American flag back here.
So if you're in your uniform, you can salute. If not, hand over your heart. I pledge allegiance to the flag,
of the United States
of America.
And to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Thank you. Jared, will you do the oath in law, please?
I will. Got my scout sign, starting with the scout oath. On my honor, I will do my best to do my duty to God and my country and to obey the scout law, to help other people at all times, to keep myself physically strong, mentally awake, and morally straight. And the scout law. A scout is trustworthy, loyal, helpful, friendly, courteous, kind, obedient, cheerful, thrifty, brave, clean, and reverent. 2.
Thank you so much, Jared. So we're going to start off our day with a fun little part that every single one of our experiments has included in it. So, Jared, can you do me a favor and go over the scientific method with everybody while I get the first experiment started?
Absolutely. So the most important part about any of the experiments that we're doing is that we're following what's called the scientific method. It's what scientists use and what we'll use today to make sure that our experiments follow a procedure so we can do things the same way each time, or if somebody else wants to replicate or do our experiment again, they know how we did it. So I'm going to share with you the scientific method on the screen here so you can see the different steps to the process. I'll kind of explain what they mean as well. All right, here we are. So the first thing that we're going to look at is the question that we're asking, right? So we want to have a question in mind of what we want answered. What is it that we want to learn from this experiment? So today we're going to learn a little bit about, like I said, static electricity, how things attract and repel one another, and different densities of liquids and things like that. So those are the things that we want to discover. The second thing is about doing background research. We want to know what's already been discovered around these subjects so that we can make an educated guess on what's going to happen at the end of our experiment. So what have scientists already learned? Our third step is to make a good guess at what the answer is. And that's what here it says construct hypothesis. Your hypothesis is your guess. It's an educated guess because we've already done our research on what's going to happen after the experiment. What are the results going to be? All right, so then of course we get to do the fun part, which is to actually test it with an experiment. We have several of them planned for today. And then at the end, we have to figure out whether we were right or wrong with our guess, our hypothesis. Was it supported? Yes. Well, of course, we want to write that down and report what we saw, any results. And even if we were wrong, of course, we still want to report those results. It's not really about being right or wrong with your hypothesis. It's about what you learned. We want to write down any observations that we made, what happened. And that way, if we want to try it again, we know what to change. If we change anything the next time, that's called a variable. And we only want to change one of those variables at a time so we can see what that one change did for our hypothesis and for the experiment. So we might have a new hypothesis, a new guess, what will happen if we change one thing. Anybody have any questions on hypotheses or the scientific method? If you do, make sure you put a comment down below and we'll answer your questions here on in our meeting today. Looks like you're set for our first experiment there, Brittany.
I sure am. So this first one we're going to be doing is called the sinker flow experiment. So, you know, we just talked about the scientific method. So we're going to start off with, we're going to have 3 glasses, and each glass we're going to fill it about halfway. The first one we're going to have plain water, and the second is going to be salt water, and the third is going to be sugar water.
Plain water, salt water, and sugar water. Okay.
So I'm going to pour my water after my fingers are stuck on the outside of the container. And while I'm pouring the water, think about it. So we're going to use potatoes. And the potatoes are going to we're going to put one in each of the different solutions. Think about it, Jared. What do you think is going to happen when we put the potato in the different types of water?
Well, my guess is there's going to be a little bit of a difference on how high or down or how far down the potato will float in these waters. And I think I've heard that sugar water is the most dense between salt and plain water. So I think that since the sugar water is the most dense, that means the potato will float the best in that water. That's what my guess is.
That's your guess?
Awesome.
Got to get my pouring skills there. I have a habit of spilling everything everywhere. Okay.
Here's my guess. Sugar equals best float.
Okay, so we've got our plain water. We're going to put salt into this one.
Okay.
It's going to be about 2 tablespoons, but it may take a little bit more. I'm going to fill up I'm using my Penguin salt shaker.
I love them.
And we're going to fill this up about, there we go, 2 tablespoons, and we're going to dump it in. And we're going to stir it around until it dissolves as much as we can get it to dissolve.
Great.
Then, once we do that, we're going to do that again. But what do you think we're going to do now?
Well, we just did the salt, right? So now we got to do the sugar.
Yes. So we're going to put similar amount of the sugar in just so we can evenly see how it works. Mix those up. Real good. Okay.
This all looks like stuff I have in my house. So if I'm a Bear Scout, I can definitely practice these experiments at home too, right?
Exactly. This morning the other day when I was thinking about stuff, I was like, what should we do for super science? So I started looking around my house and I was thinking, I found everything for this experiment in my kitchen. My potatoes,
Great.
My water, my glasses, my sugar, and my salt. That's all I needed. So now this is the let me pull up the chart. I have created a chart for you guys to look at. It's just pulling up right now. Okay. So this chart, do you see the chart, Jared?
It's still loading for me, but I think I know what it looks like. There it is.
Gotcha. There we go. So as you can see, my sink or flow experiment was what your prediction was that the salt would float or sink, Jared.
With the salt water, I think it's going to float, but not as well as the sugar.
Okay, let's see. You're right. It floats. Now,
Look at that.
look at it. Can you see it? It's floating.
Yeah, so I can see it. We'll have to show our viewers once we stop sharing the screen afterwards as well, so you can see all three of them.
Yes. Let me see. Let me unshare this. You see it now?
Mm-hmm.
Awesome. So that's floating, as you can kind of see it in the top. And then what about the plain water? What did you think?
I think it's going to sink.
Okay, let's see. You're correct.
All right.
Okay. Are you going to be 100% correct on your hypothesis? I don't know. What about the sugar water?
So sugar, I think it's going to float the best. So it's going to be the highest up out of the water.
Okay, let's see. Actually, it's floating. You're correct, that one. However, it's sunk just a little bit more than the salt.
Oh, so the salt water is actually more dense.
Yes. So
Very cool.
this experiment was an experiment on density. So
Awesome.
in the end, the plain water was more dense than the potato. The salt was the least, and the sugar was
Somewhere in between.
middle. Yes.
All right. So my result: sugar not the best, but it does float.
Yes. Awesome job. So, any questions? Anybody? Do you have any questions, Jared?
Not so far.
Well, there we go. We just were able to put our scientific method into play. And this was our first experiment. So we're going to move on.
If they want to follow along with their own chart with their own things, if we are able to show that again, on that left column, we just had our different variables. So the different steps to the experiment, with 1 cup having plain water, 1 cup having sugar, and 1 cup having salt. In the middle was our hypothesis, where we said, is it going to float or not? And then that far right column is the results. So what actually happened? You can always add more rows after that if you change any of the variables, whether you're adding more sugar, more salt, or maybe using a different liquid altogether.
Yes. There. Should be loading right now. There you go.
Ah, there it is.
So that top chart, really simple, but it keeps your mind organized as you go and do your experiment.
Very cool.
Awesome. So now, Jared, are you ready to move on to static electricity?
I sure am. It's
Okay.
electrifying.
Yes, it is. It's shockingly exciting. So, want to talk about atoms while I clean up this last experiment and move on to the next one?
Absolutely. So this next experiment is all about, like we said, static electricity. And let's talk a little bit about what that is. So as you guys might know, everything in our universe is made up of atoms, which are very, 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 very tiny little things that everything is made up of. And the different kinds of atoms have different numbers of protons and electrons that make them up. So, and neutrons, of course, but we're talking about the protons and electrons today. So the protons have a positive charge and the electrons have a negative charge. A magnet, those two things will attract. But as we showed earlier, where you're rubbing atoms together, like my socks and the carpet on the floor, the atoms kind of bump into each other, and electrons from one atom on another will start to rub together. And those extra electrons can build up, which creates a little spark of static electricity. And the more you do it, the bigger that static electricity grows until eventually you have a discharge, which is what we saw when I shocked myself on the piece of metal over there. The other cool thing that you can kind of see as you build up a charge on something is when things repel one another. So for example, sometimes when you rub your feet on the carpet, or if you are wearing something really fuzzy for a while, you might start to notice that your hairs are sticking up. It's because each of your hairs have a positive charge and they repel against one another.
Like
You can
this?
also see it when you do it with a balloon. And yeah, you can kind of see Brittany's hair is attracting to that balloon because they have different charges, but they kind of repel from one another because they have the same charge. Very cool.
Awesome. Okay, man, that's some exciting stuff learning about atoms. So our first one we're going to do is we're going to take a balloon. This one's going to be the static. Is it going to cling to the balloon or not cling to the balloon? We're going to charge up our balloon, and we're going to see what sticks to the balloon and what doesn't stick.
All right, so you just have like a normal balloon there, and then what are we going to charge it with?
We are going to charge it with our polar fleece.
All right, so fleece, something nice and fuzzy.
We're going to charge it up, and then we are going to see what of our stuff is going to attract. But first, I'm going to put up that screen again to show you a way to track your.
While you're pulling it up, I want to say hello to the folks that are joining us on Facebook Live.
Yeah,
yes, we will have this video available later. It'll be available on our Facebook page, but also on our Scouting at Home website. And our first question was from your friend Julia Hearn, who, or I guess it wasn't a question, just talking about water temperature could be a different variable with the experiment.
I like it. We did talk about variables, and in this one, we're going to try, I think we might try something 2 different ways.
Oh, and hello to the Berkeleys and the Griffiths who are following along, along with the Vannicks and the Turnises, I believe.
Wow, nice. Welcome, everybody. So I have it up on the screen now. It's just another simple chart. Basically, it's our object that we're going to try it against, our prediction, and then our result. So
fantastic.
First off, Jared, we went through this a little bit earlier, but remind me, what did you think the tissue paper was going to do?
So I think the tissue paper is really lightweight, and I think that there will be attraction between the balloon and the tissue paper. I think that it'll stick to it.
Okay, so we're going to take our tissue paper. Should I have it open or closed?
I'm going to say open.
Okay.
More surface area.
More surface area? Okay, let's try it. Let's see. Is it going to stick?
Looks like no on that one.
I don't think so. Should we try? What do you think about trying it a different way?
All right, so our result was no, but maybe something that we can change, a variable on that, is maybe a smaller piece of tissue paper. Maybe if we cut it up a little bit.
Okay, let's try that. Let's see. Ooh.
Ooh, look at that.
Oh. There we go.
Oh, working.
It's working. Can you see?
I can. Yep, it's pulling right off of the ground there.
There we go. So we had 2 different we changed up the variable, and the first result was not positive. It did not stick, but when we changed it up, we found a way that it stuck. So awesome job. There's a variety of other things you can do, you can test when you go at home, and it's all basically stuff that you can find at your home or in your local grocery / Dollar Tree stores. Trying to be fancy with my words. I should probably just keep on with the more simple. That'll be more straightforward.
If you stop sharing the chart there, maybe we can show the folks at home the tissue paper, or maybe one more of those.
Yeah, let's try it one more time. Okay. Let's charge up our balloon. Okay, and there we go. You see it? I'm off the ground.
I see it. Perfect. Yep. So a different charge between the tissue paper and the balloon means that they attract.
There we go. Awesome. So I've got a few other things next to me. We'll just show you so you can see. We have some string you could try. You could try some cardboard. You could do some construction paper. And even aluminum foil.
Something metal. I wonder if that would discharge it.
I wonder. Now, if for some reason there's an allergy to latex, because balloons do have latex in it, you could use a plastic cone to try the same thing. So plastic cone, just try it to see if it creates that same bond like the balloon with the charge. So,
cool. So maybe as part of your result chart there, you can see which things were most the most affected by the static electricity versus the other ones.
Yeah, that's an awesome extra part to the experiment. So another thing you could do with the balloon is not just if it sticks, but if it follows the balloon as it goes along. You could, and you could try it with a variety of other objects, such as a ping pong ball or aluminum foil, and see if that is another availability of charging the balloon, and see if it follows along.
Okay, so because the ping pong ball is light enough, maybe it kind of follows the balloon.
Yeah.
I've also kind of seen that with like a stream of water. If you have water dripping down from your sink, you can put the balloon next to it, and sometimes it'll kind of push the water away. It feels like using the Force from Star Wars.
Yeah, exactly. I do that accidentally once in a while when I walk over there and I'm for some reason charged.
Happens most to me in the winter when the air is a little bit drier, and just seems to happen more then.
For our final static electricity experiment, we're going to have a liter bottle, and we're going to have some, you know how beanbag chairs are full of little beads of foam?
Yeah, exactly.
Well, we're going to take some of that, which coincidentally you can find at your local Dollar Tree. This was the only thing I had to go out and buy today for this experiment. Well,
oh, cool. Able to find everything else at home.
Yes, everything else I had at home. I actually had this from another experiment we did for holidays event a couple of months ago at camp, so I didn't even have to go buy those, but they're found at your local Dollar Tree.
Quick question from the group. Will the chart be available to download afterwards? Yes, we can definitely make that available.
We will make everything, we'll make the chart available, and we'll have the list of materials that you need to do them. And I don't know, Jared, do you think we should, I would be even willing to type up the experiments and put them on there too.
Yeah, we can do the step-by-steps.
Awesome. So foam beads can be kind of messy. I don't know about you, Jared, but when I play with these, it becomes a messy mess around me.
You do not want your beanbag chair to open up.
Nope, it sticks everywhere. So what I do is I open up the bag and I put it into a Ziploc bag. Pretty simple here. And then I take it. Have you ever made a cake, Jared?
Once or twice.
Well, how do you put on frosting yours?
Well, usually I would cut a little slit in the corner of the bag and kind of squeeze out the frosting onto the cake. Are we going to do that with these foam balls?
Yes, we are. So all you have to do, make sure your water bottle is dry before you start. But you put about 1/4 of a cup of foam balls into your bottle. And before you, make sure it's all at the other end before you start this process. So you don't start with it. And then I just take it and slowly funnel it into the bottle like this.
Looks like it's working pretty well. No mess.
No mess. And now I did it a little bit. I filled it most of the way full that we need it already, just because it takes a little bit of time. But that's how I do that and keep it from making a big mess around my table.
Cool.
So then after you do that, you take the lid. You twist it, make sure it's on tight, because if you don't put it on tight, then what'll happen?
Making a mess. We don't want that.
Yes, we will. So this is calling the flying bottle beads. What do you
The
think?
question we're asking on this experiment, right, Brittany, is like, will the static electricity affect the beads through the bottle, right?
Yes, good. That's a great question. What's your hypothesis? What do you think is going to happen, Darren?
Well, I've seen something like this before, and because the experiment is called the flying bottle beads, I'm going to guess that yes, it will affect it. That you're going to see the beads kind of fly all around.
Okay, let's see. I was practicing earlier, so it's got a little charge to it already. So, Can you see the? Let me see. You see it flying?
So just like the balloon, trying to charge it through use of your hair. Oh yeah, they're starting to kind of pop around and spread out in the bottle.
Yep, and I'm not even shaking it real hard. But as you can see, they kind of do it on their own. They're charged, so they're flying around.
Oh, look at that. They're all stuck to the outside edge of the bottle.
Yep. Even as I turn it and shake it or twist it, they're flying around because of the charge.
Oh, interesting. So let's ask the folks in our comments here if the beads are sticking to the bottle. Do they have the same charge or different charges? And if they are bouncing around away from each other, do the beads have the same charge or a different charge? We'll wait a couple seconds to let our folks at home try and answer that for us.
Awesome. Okay. While we do that, I'm going to set up for the next one.
All right, so we know if the bottle and the beads are the same or opposite. Hello, Mr. Grabowski. This one looks exciting. That's a big glass of water.
It sure is. Okay.
And hello to Mr. Mark Raphael. Thanks for joining us. Well, Brittany is setting up our next experiment, wondering if you guys think the beads in the bottle have the same charge or a different charge when they are attracting there. So I'm seeing water, I'm seeing oil. Aha! Looks like the Lolos, window low. The first ones to answer, they think that the bottle and the beads are opposite. And you guys would be correct. Opposites attract. Which I guess would mean that the beads inside the bottle are all the same charge, which is why they're kind of bouncing around away from each other.
Very nice. So, are you ready to move on to our color morphine experiment?
Ooh, well, we have one last question. How long does stuff stick to a balloon? I think that is a great experiment for you guys to try. And Sawyer thinks that the beads have the same charge. You'd be right, Sawyer. Congratulations, your hypothesis is correct.
Very nice. Okay.
And Christian says they're opposite. Great job, Christian.
Man, we've got some very super scientists out there watching.
We sure do. All right, tell me about this next experiment. Looks fun.
Well, have you ever heard oil and water don't mix?
I have. It makes cleaning my dishes after dinner kind of difficult. The oil likes to evade my attempts to wash it off.
Well, we're going to do an experiment, and think about that while we're going along.
Okay.
What do you think will happen if I pour oil into water?
What do I think will happen if you pour oil into water? Well, I'm going to write down my hypothesis here. Bear Scouts at home, you guys can do that as well. So I'm going to write down that I think that the oil and the water will separate. So they won't want to be near each other. They're going to split into two different parts.
Okay. Now I'm going to add some food coloring. What do you think will happen when I'm going to put the food coloring into the oil?
Okay.
But when I put the oil and the food coloring into the water, what do you think will happen?
Ooh, well, I think that the water or the food coloring is more watery than oily. So I think you're going to see the drops of the food color in the oil kind of stick together. And then when we pour it into the water, the food coloring and the water is going to mix together, but still stay separate from the oil. So we'll see it kind of spread out into the water, but still be separate layers or like bubbles within that oil. Let's see what happens.
Let's see. I'm going to put 2 tablespoons of oil at the bottom of this measuring cup.
Okay.
This is a half a tablespoon, so I'm going to do it 4 times. There we go. And then we're going to make sure we put the lid on the oil so we don't spill it. That will be
good idea.
a bad thing. Then we're going to take our food coloring.
Can you hold that up to your face camera there as you drop it in? We'll be able to see a little bit better.
Let's see.
Yeah, kind of hold the oil up here with you.
Oh, there we go. This one's a little tricky. If you don't do it just right, the experiment goes wonky.
And Christian says he thinks that the oil will float on top of the water and not mix. The food coloring will not mix with the oil, but will mix with the water. I'm right there with you, Christian. I think you're right.
Okay.
And we lost your phone screen there, Brittany, but we can still see your face.
Okay. 1 second. One second, guys. Okay. So we're going to pull this up here because we'll.
Okay, I do see the little droplets of food coloring. So far we're correct. Little check mark next to my oil and water separate.
Good job there. Now.
Pouring very slowly. Oh, it's so cool to kind of see the food coloring act like a little gel ball. Oh, look at that.
Look at that. Look at the
So the food coloring is still sitting on top of the water there, huh?
It is, but as you can see,
You have to raise it a little bit for me. Oh, look at that.
Starting to separate. Slowly but surely, the food coloring is separating because why do we think it's separating?
I think it's staying separate until it reaches the water there. So I bet if we like switched it around and it finally started to touch the water, you're going to see it start to separate into that water, and we'll see the water turns different colors.
So the red is now, and there's yellows going down. It's a little harder to see.
Uh-huh.
And
Well, that is pretty cool.
Yeah, so we'll leave this off to the side for a minute, and I'm going to put my lid on my food coloring. I'm going to move this in the oil, and I have one more thing with this one.
Okay. So Christian, you can also put a check mark next to your hypothesis. It floated on top of the water. Didn't mix with the oil, but it did mix with the water. Very good. All right, what's the second part here, Brittany?
The second part, we're going to take milk and Dawn dish soap. What do you think is going to happen when I add those
and dish soap? I don't know. I can't say I've ever mixed those two things before.
Well,
what do you guys think it's going to happen at home?
So,
hello to John Sanders. Thanks for joining us.
What we're going to do is we're going to take the milk. And we're gonna put it into a plate. What does this remind you of? Probably all the movies. Cat.
Oh, like a saucer for my cat.
Yes. Yes, yes. Then I'm actually gonna do this.
Awesome.
While that works, and I'm gonna put, just like the last one, put 3 drops of each color.
Awesome. I see 3 drops of red.
And there.
3 drops of, what color is that? Is that
Well, the
purple?
first one was yellow, the second one was red.
Oh, okay. And then blue.
Blue. And this one we're gonna put some green in it.
I love it. They look like little Mickey Mouse heads.
You kind of do. Okay. Now we're gonna take the Dawn soap. How are we doing, Jared? Can you see it?
I can. So our question is, what will happen with the Dawn soap, the milk, and the food coloring? I guess the real question is, what happens with the dish soap and the water, and the food coloring there is to show what happens, right?
Yes. So, look at that.
Whoa!
Is that not awesome?
That's so cool. That was just a little bit of dish soap.
It's just a tiny little drop. Basically, the soap and the milk, the soap has a tail made up of a tail, which is kind of like a fat. And so
Okay.
soap was made from lye and wood ash, which is kind of like a fat, which is in the milk. So the dish soap is trying to get all the fat cells, and that's why it spread out the food coloring.
Oh, interesting. Okay, so the milk has fats in it. The soap has fats in it. So it's like sucking the fats together, which is what spreads the food coloring that was in the way apart.
Yes.
That is really cool. I bet you can make some really cool art with that.
Yeah, actually what we're going to finish off this experiment with is some art. So glue, right? It's white, just like the milk.
You don't want to mix those up.
No, let's not mix that one up. So we're going to squeeze it here onto our plate. I'm putting it on a throwaway plate because glue, it's going to stick. So you're going to get all that glue out and put it on your plate. What do you think I'm going to do, Jared?
Well, I'm hoping that you're going to do the same thing with the Dawn, because I want to see how that works with the more the denser glue there. Okay.
So then we're going to put our colors again. 2, 3, 4. Okay. And then we're going to put our red. And so everybody can do this at home themselves too, because most people have some sort of glue and dish soap.
All right, so going through a scientific method, our question is, will the glue behave in the same way as the milk? And my hypothesis is that yes, they are similar enough that it'll work, but it's going to be a little bit slower because look at that. It's like watching the previous experiment in slow motion.
It sure is. And look, it's like an eyeball almost right there. It's climbing out. Basically, the glue is a synthetic version. It still has the polar and the non-polar side. So it's spreading. So there you go. Now, if you leave this like this and let it dry, you have a really pretty art project.
That is very cool.
Yeah. So that is that one. Have any questions, Jared?
We got some comments from the group. Yep. So Pack 91 says they have half of their den here watching along with us.
Nice.
The Griffiths say that we should do it with some more milk. Christian says that the soap will spread the colors out. You were right there, Christian. Sam says that's amazing. I'm right there with you, Sam. I think that was super cool. And Ben also says, yes, it's gonna spread out like the milk did.
So awesome. We have one final experiment. We're gonna do
Okay.
some layering.
Mm.
Yes. So our
Oh,
color layering.
we have a request from the Vanix. They say if you spin the glue plate, it makes it look really cool too. So maybe we can try that at the end.
Yeah, maybe at the end. That'd be awesome. I'm gonna bring over our last set of ingredients.
I've been very impressed so far, Brittany. What is our last one?
Our last one is color layering. So we're doing some density.
Okay.
Okay. So hopefully we're gonna pull our, change it over so I can see you guys. I have sugar. I have 6 glasses. I've numbered the bottom of each glass.
Okay.
And then
sugar.
all sugar. And I've done 1 through 5, and then I have an empty 6th one.
Okay.
So I'll hold these up. The first cup, I put 1 tablespoon of sugar.
All right. So number 1 has 1 tablespoon. Got it.
So the next one has 2 tablespoons of sugar in it.
Okay.
What do you think the third one's going to have, Jared?
Well, it follows our pattern. 3 is going to be 3 tablespoons.
Correct. And 4?
Of course, 4 tablespoons.
And 5.
5 tablespoons.
Yes. And the 6th one we leave empty.
Okay.
Okay. So we're going to take our first one. And for each of these cups, we're going to add 3 tablespoons of lukewarm water.
3 tablespoons lukewarm water. Okay, so each of them has the same amount of water, but different amounts of sugar.
Correct.
All right.
So I'm going to take my tablespoon here, and I'm going to put 3 tablespoons in each. Why do you think it needs to be lukewarm?
Well, probably it mixes better together with the sugar. I know that in a lot of experiments, when you add heat, it makes the cool stuff happen. So I'm gonna guess warmer water makes it dissolve a little bit faster.
Yeah. 2, 3, 1, 2, 3, 1, 2, 3. 1 second. You hear the bing?
I do. You're helping us count.
Yes. Okay. 1 second. We'll get you guys so you can see what I'm doing. It's like I'm looking up
color layering. So we have sugar, we have water. Are we going to use our food coloring again?
We sure are. While I'm waiting for this to load, I'm going to stir each of. Really popular.
Apparently.
Really popular. Oh, shoot. Keep stirring them until it's pretty much mixed together. So I've got 1, 2.
You could angle your screen down and then we can see you stirring it there.
Yeah, it's on. The other one's almost on.
There we go. Ah, now we can see it.
There we go. And we're going to keep on mixing. I don't want to give you back feed on my, there we go.
Got it.
There we go. We're mixing, that one's mixed. What do you think? Do you think it's getting harder to mix this with the sugar as I go, Jarrod?
Well, as you have more sugar in each progressive cup, I'm going to guess it takes a little bit longer for it to dissolve. It's going to get more and more dense.
A little bit more dense. And then there, once I get it going, it goes pretty well. You could also do this in bigger cups. But for today, we did it in a smaller cup. There we go. And when I first tried it, I didn't use hot enough water. So it took a lot longer to mix together.
It's a lot of water with only, or a little bit of water with a lot of sugar there.
Oh yeah. If you drink it, it'd be, you'd be
Sugared up.
on a sugar high. There we go. How's that? Better?
That's great.
Awesome. There we go. Back in business. So now that we've done that, we'll move on to the next step. So after we've dissolved it, we're going to add the food coloring to each of the first 4 cups. And the last one, we're going to mix. How often do you buy food coloring, Jarrod?
Not very often. It usually lasts quite a while because you only need a little bit to go a long way.
Yeah. Well, when you buy food coloring, how many colors come in it?
Usually just 4.
Usually 4, yeah. So the first one we're going to do is we're going to put yellow, and then we're going to put red, and then we're going to put yellow and red. What does that make?
Orange, my favorite color.
Yes, I thought so. And then we're going to do green, and what's the last one?
Blue.
Blue, yes.
So each cup is a different color. We're not going to mix them together this time.
Nope, not mixing them together this time. Yet. Then we're going to take all of these and mix them together, so it's colored. And then we're going to take, you know, that empty cup that we were holding on to? After I mix in this blue, I'm going to take half of this blue and put it in that cup.
All right, so the blue, which was the 5 tablespoons.
Yes.
Right? That goes on the bottom.
It does. What do you think? Why do you think we're going to put it on the bottom?
Well, I think that we're going to try and see if we can keep the colors from mixing together and make different layers. So if you do the heaviest on the bottom, then it's in the right place, and then the lightest one on top.
You would be correct. So the more sugar, the denser the drink is. Okay. So why do you think I have a spoon?
I don't know. Why do you have a spoon?
I have a spoon because in order to layer it, I'm going to put it against the side of the cup, the blue cup, and then I'm going to pour it down the back of the spoon.
Oh, okay. So it goes in there a little bit easier.
Yes, and it lays right where we want it to lay instead of falling, splashing around. Then we'll take our 3rd cup that I measured. Why do you think I wrote the numbers on it so I would know?
Probably so you don't forget which had the most and the least amount of sugar in it.
You are correct. And then we're gonna.
Or folks at home, let us know what your hypothesis is if you think this is going to work. If it's going to stay nice different layers, or if we're going to get any mixing. I guess if it mixes, we're going to get kind of one big blob of a color, huh?
Yeah. Orange, and then we're going to do red. Takes lots of concentration.
Mhm.
And then our last one, we're going to take and
I love that this is such a simple experiment, but really shows the different densities of water so well. I mean, all you need is food coloring sugar and water, and you can see how even something like water can be made.
okay.
Whoa, to be made
See?
different. Wow, look at that.
So it's a little, you can see it. Can you see it, Jared?
I do. I see the blue on the bottom. There's definitely green in the middle, and definitely red on top.
There we go. So it worked. Everything I had in my house, water, like Jared said, it was a simple one. However, you have to have some patience. If you dump it right on there, then it will just go right into each other and be a big blob.
Interesting.
Yeah, so that's one of my favorite ones because it's so pretty and colorful, and it takes a little bit of patience. So, any questions?
Hannah thinks that's pretty cool too.
Hannah thinks it's pretty cool. That's awesome. So, because the sugar molecules take over the space, which becomes denser, which is why each one lays on top. The denser it is, the farther down it has to go. So
Gotcha.
That's all I have for today. We went over each of the requirements for super science for bears. If you want to try it at home, we will put it up for you so you can follow along and rewatch the video. If anybody has questions, we'll put them in the comments below. I had a really great time, Jared.
Lizzie says that she would love to drink that rainbow. Sugar water, I don't blame you there, Lizzie, but I bet it is a little too sweet. I would be interested to see what happens when you put that cup in the freezer. I wonder if the sugar would fall out of the water or if it would freeze fast enough that you can still see the layers. So that's going to be my experiment for later.
I'm going to say, maybe I'll put it in and we'll post a picture.
Cool. We'd love to see pictures of your experiments that you're doing at home as well. If you do the same things that we do, or if you find other cool experiments with density and static electricity, make sure you post those pictures up with the hashtag scouting at home so we can see what you guys are doing. And I just want to thank you, Brittany, for putting all this together. You're very prepared following the scouting motto, and this has been really cool. I've learned some cool stuff today, and I always love colorful experiments like these.
Great. Well, I hope to see some more people back tomorrow for a great day of more adventures. Have a great night, and hope to see you soon.